In this video, we are going to do something which is trending nowadays, that is MCP, Model Context Protocol in IoT perspective. So we will be creating an MCP server for our IoT system using Raspberry Pi 5, RGB LED and soil moisture sensor. We will use Claude Desktop as an MCP client to query the IoT system and get the responses in natural language. You can even control the LED color through Claude by natural language. So here you can see the architecture workflow. So first we have this Claude Desktop, that is an MCP client. Then we use something called MCP Remote, which is a bridge software for converting our server sent events by this Raspberry Pi MCP server to STD.io, because the Claude Desktop understands in STD.io format. And then we use ngrok tunneling tool to expose the MCP server to the internet. So here you can see Raspberry Pi 5 has an MCP server which is integrated with sensors like soil moisture sensor and RGB LED actuator. So this one is connected and this exposes MCP server. So and we use ngrok to expose this server, and we use Claude natural language and get the results using Claude Desktop. Hello everyone, welcome to IoT Frontier. My name is Hariharnath. Today I am very excited to present this tutorial to all of you. So let's get started. First, we need to connect the sensors as per the different circuit diagrams I am going to show. So first thing is you need to have soil sensor, so which has 3 pins, VCC, ground and digital out. So there would be another analog out also, you don't have to worry about, and connect to these pins. And RGB LED, you have to connect GPIO 16, 20 and 21 and the common cathode to ground, but in between these you need to have something called resistors, which are 220 ohm resistors. So this is how you need to connect the resistors in between, and so you can use the wiring based on the GPIO pins that I have mentioned in the table. So you can use this diagram to connect. So 16, 20 and 21 I am going to connect to RGB LED, and you can see another one, that is 26. So GPIO 26 we are going to connect, so that is here we are going to connect to soil moisture sensor, and we can use the 3.3 volts for LED and 5 volts for the soil moisture sensor as per mentioned here. And soil moisture sensor will have another connector here, so you need to use this kind of connections. Only thing you need to change is this GPIO pins, that whatever I have mentioned. So you can use that because the code is made using those numbers. So next thing is you need to start your Raspberry Pi, so by connecting to the power supply. So once that is done, you can simply use SSH. So for that, open any command prompt, and here I'll do SSH. So you need to know the IP address of Raspberry Pi. So you can use Angry IP scanner, and you can use the range of your network, the ping response as sort, and you can find 80 and 443 is only exposed by Raspberry Pi 5. So that's why you can consider this as your host, and you can try 192.168.29.195. You need to use pi @ as a username. You need to provide your password. You will be logged in like this. And if you want to look into the Raspberry Pi setup, then you can follow my previous video from the top right corner or in the description below. So after that, you need to use sudo update commands so that the repositories are updated, and then you need to paste these commands so that you can install all the relevant libraries. So for me it's already installed, so it may take for you 5 minutes. Next thing is we need to set up our project. So first thing is you need to install UV. So UV is a fast package manager. So we want to use some packages, and this is going to help. So you need to use this command to install that UV. So we can see UV and UVX are installed. Next you need to just refresh this command line so that you will get all the latest values. Next thing is you need to get into the Pi IoT. So here I have already created Pi IoT, so I'll just remove this and just go to Pi IoT. Next you need to use UV init. For me it's already initialized because I have done previously. Next you need to use UV add fast MCP GPIO 0. So fast MCP is for the MCP server that you want to create, and GPIO 0 for controlling your GPIO pins to control the LED as well as read the values from soil moisture sensor. Next is you need to create a server. So nano server.py. So I have already one server, so I will use IoT server.py and I have to paste my code. So I'll provide the complete code in the Git link in the description. So you need to paste this code. So I'll quickly go through. So first is we are using fast MCP. So we are importing it, and GPIO also we are importing. So we have this digital input device. Another is RGB LED library directly available. So we initialize the MCP server and give the values of soil moisture sensor to this, and also initializing the values of RGB LEDs. And the important thing that we need to look is this mcp.tool. This decorator has to be used so that the MCP client, whenever it is reading, it will read the appropriate functions. For example, if you type what is the moisture level of my plant, then it can understand the values that you have provided in the doc string and use this function so that it can return the values based on your query. So here we are simply using status is dry if soil value is 1, else wet, and we are returning this value. So this value will be sent to the MCP client that we are going to use. And same way we are using another tool here, that is soil health with LED. So for example, if it is wet, we are going to make it green. If it is dry, we are going to make it red. And another way is also we can control the LED manually. So we can provide led.color is equal to RGB. So whatever you type in your MCP client or Claude Desktop, like if you want the color as orange, then it will automatically set the values of RGB that will be shown displayed on the LED. And finally, we are starting this MCP server by using mcp.run, and the transport is SSE, that is server sent events. So this is the transport that we are using, and host we are using the default one and port 8000. Now use Ctrl X, use Y to save it and enter. Now we have saved it. So SSE is nothing but a server sent events that enables HTTP based communication between MCP server and clients. So that's why we have used that. Next is, if you want to run the code, you need to type uv run IoT server.py. So here itself you can see the fast MCP started, and it is also running here with this URL. So one task is completed. Second task is we need to expose this system to the internet, because this is only local to your router. So for that we need to keep this as it is running and open a new command prompt. And here also you need to use ssh pi @ you will ssh here, and after that you need to install the ngrok. So to install the ngrok, you need to paste this full command. So it will get the ngrok and then it will update as well as install ngrok. So enter this. So for me it is already installed, and next thing is you need to go to ngrok website. So this is the link I'll provide you, and in the ngrok link you will have to log in with your account. If you don't have any account, you can simply create an account and go to getting started your auth token, and here you need to just copy this and save in your notepad. And simply you can also use this command here, that is ngrok config add auth token, and here I'll just paste it here, and here I need to provide my auth token. It didn't copy automatically. So now you can see my auth token is saved. Next is you need to use ngrok http 8000, because we are going to listen to 8000 and expose it. So automatically it will create one random website name and paste it in your notepad again. So now we have two things running. One is your MCP server, and second is your ngrok, which is exposing your MCP server to the internet. So immediately you can use your browser and paste your URL and /SSE. So this way it will ask you to visit the website. So don't worry with this, because this is on the browser it will be asking, but on the systematic or the programmatic way it won't be asking like this. So you can click on visit website and you can see event, endpoint, and the data, everything is shown like this. If it is shown like this, which means that your ngrok is working properly and also your MCP server is working properly. Next thing is open another command prompt, and so here you need to have Node.js installed on your system. So Node.js, so we need to type node-v and you can see the version, and npm also you need to type and use version. So if you have Node.js and npm, then this tutorial is going to be working. If not, you need to first go to Node.js website and use this Windows installer version.msi to install it for Windows, and there are other ways also you can do. So first install it and use this command to check npm and Node.js is installed properly. So once this is done, we need to install something called MCP remote. So as I mentioned in the starting, we are going to use something called MCP remote because we are exposing this MCP server using SSC, but Claude doesn't understand or support SSC transport layer. So that is server sent events. It only understands stdio format. So for that we are going to use MCP remote to do this conversion, bridging this capability. So you can use npm install -g MCP remote to install that, and once it is added you will see something like this. Next thing is you can check whether a command of npx MCP remote, and this is the SSC link that we have, and once you see this, which means the server is connected using this MCP remote from your desktop. So right now this is my desktop, you can see this, and from this I am able to connect to the MCP server. So this is acting as a MCP client. So I can use Ctrl+C to stop and Y to terminate. So once this is working, we can simply use Claude Desktop. So you can go to Claude Desktop first, File, Settings, and Developer. So here you might see this as blank. I can simply delete my previous one and just click on Edit Config. So you need to use this Edit Config. So it will open your app data, and here you can see that JSON file. So you need to open this, edit in your Notepad or Notepad++, and just remove everything. And if you have something else, then you can append this server alone to the MCP servers. So I'm using Pi servers, and the command is npx MCP remote, and the URL that I have used, and /SSC. That is very important. So you can save this. So once this is done, you can exit the Claude Desktop. Like in the task bar, you can see this icon. Click on this quit. So you have to completely quit, not just the window, and just start again. Now you can see the Claude has loaded and you don't see any errors for the MCP. Again, you can go to File, Settings, and Developer. So you can see the Pi server is running properly. If you see some errors, you can go to logs and try to find out what is the error. And again, you can edit the configuration. So next thing is we can go to the chat, and in the plus icon, you can see the connector Pi sensor is already active. You can just turn it off or on and keep it on so that you can ask queries for that. Now let's try couple of things. So now I'm asking it to tell me the moisture level of the plant. So now it will try to understand whether this is our MCP server. So it will ask us to allow, and you can click always allow. And you can see the soil currently is wet, and it is also giving some other additional details like it has plenty of moisture, so no watering is needed. Next, I'll try to remove this soil moisture sensor from the plant, and I'm keeping it out of the soil. Now again, I'll ask. So it will check the moisture again and tell me whether I have to water it or not. So it is saying the soil is now dry, your plant needs watering. Cool. So first I'll just check the health of the plant. And let's see if the LED changes. Yes, now you can see the LED is also changed to red because it is dry. Now I'll place this sensor into the soil again, which is already moist, and again ask for the health of the plant and see the changes in the color of the LED. Now I can see it is green in color because the plant is healthy. Now I want to individually control this LED, so you can simply ask. So I'll ask to change the color of LED to blue. I'll allow this and you can see the change has been done. You can use mixed color, like, so you can use light green. So it will try its best to change to that color. We can also ask change to different color, that is orange. It will do some modification and change it to the orangish color. So using this RGB, you can try to control everything. And that's all for this video. And this is how you can use natural language to query your IoT system using MCP. If you found this video informative, please type helpful and smash that like button. In the upcoming video, I can add DHT11 sensor and other sensors to this IoT system and create a soil health monitoring system. If you ever wanted to learn IoT from scratch, then you can check out my course on Udemy from the link in the end screen or from the description. Your support means a lot to us and helps us keep creating more content like this. So please subscribe to the channel and hit the bell icon. Thank you for watching, and I'll see you in another interesting video.